Hi, Sam Schiffman here, and welcome to the next episode of What's on My Mind. Today I'm going to talk about why agentic development is more like teaching than it is like traditional coding. So am I saying that all developers should go back to school for the humanities? Well, maybe. Let's be serious. There's always going to be a role for people who know how to do Fourier transfers and why you would use the ReLU activation function over another activation function, right? There are always going to be positions for people who do that kind of low-level coding, but the reality is that that's not the work that most people in software do. Most developers are really working on business process modeling, right? They're building applications where they have it can be a business process, but it doesn't have to be in a traditional business. That some sort of process that's a set of rules or set of things that's going to happen, and they're trying to represent those in code, right? And that's great. But as I've talked about in my last couple of conversations, it's not where the future is going to be because it hits a significant limitation. So let's take an example here. I'm gonna, in my last episode, I talked about patient flow, and so let's take an example along those lines. And I'm going to simplify greatly here. Let's say we have an emergency room, so we're just going to have an ER here, right? And let's say it's got maybe, okay, we're going to give it 6 beds, right? So each of these is a bed, right? And we'll give it a waiting room over here, right? So there's some sort of waiting room, okay? And let's put some rules on this. Let's say in order for a patient to be in a bed, there needs to be at least one nurse for every 2 beds. So if we have 2 nurses on, right, we can have these beds filled, but we can't fill these 2 beds because we just don't have the staff to manage those, right? So we start getting patients in the door, right? We're going to have, P1 comes in the door. The P1 is going to be here. Patient 2 is going to end up here. Patient 3 maybe is over here, right? Now we're starting to get to a point where we might be going to run out of space, right? Again, I know I'm greatly simplifying this for what realities of a hospital are. But the hospital is going to have some set of policies about what you do now, right? So that maybe the charge nurse or the physician in charge is going to say, okay, I'm starting to run out of capacity. I maybe need to do something about this. Patient 4 walks in, needs, and now I'm starting to see people in the waiting room, and they're starting to back up. I have P5 out here. I have P6 out here. I have P7 out here. The time that they're waiting is starting to get to be unacceptable. What am I going to do? And the hospital is going to have a set of policies, a set of things that they probably are going to do, right? They're going to say, okay, let me go find a floating nurse somewhere who can open up these 2 beds for me. Great. I'm going to call out to my inpatient floor, or I'm going to call out to an outpatient clinic that I have. I'm going to call out maybe to the OR, see if there's any nurses who are floating nurses who could come to my aid and open up these beds, right? And it's going to have a set of escalation policies. So your typical approach from a software point of view would be to say, okay, I'm going to model that, right? I'm going to write a service that's going to say, okay, it's going to know how many nurses are on the floor and how many nurses it needs for a bed. and it's going to see that there's a backup going on, and it's going to execute those set of policies of calling out to these various departments and seeing if it can find a nurse, right? All of that can be automated, and that's great, right? The problem is, what's the old adage? Every plan, every strategy is great until you get punched in the face, right? Your plan does not survive first contact with the enemy, right? And that's what we find is, these plans, which are important, these policies are important to give us structure and give us direction to go, but they're executed by people because they need to be flexible, right? There may be situations where it needs to be a nurse. Normally I would go to the inpatient first, but because of some overcrowding in the inpatient, I, as the person in charge of the ER, I'm actually going to go to the OR first, even though I wouldn't normally pull a nurse from the OR. Situations change, right? So what we want is a system that can respond to all of these different changes, right? And that's what we've talked about in the past, is we don't want traditional process modeling. What we want is agentic systems that are able to continue to work in the face of things not being the way that you expect them to. But when you want them to do that, what you give up by saying that is you give up the determinism of knowing exactly what they're going to do, right? They're not necessarily going to react the same way that you expect them to. And so how do you get them to do anything that's positive, right? And this is why I think it's more about teaching, right? When we talk about an agent, right? I've in my first video, I talked about how an agentic agent starts with the LLM in the middle, right? And then it has the prompt on the outside, and then tools and external memory on the even outside of that. And then there's, I think I mentioned, there's internal memory here, right? And internal memory is everything the LLM is trained on and or fine-tuned with, right? So this is the structure, and how you put these things together, right, is largely about how you write the prompt, how you think about giving the LLM the context that it needs to make a good decision, which is not telling the LLM what decision to make. It's more like teaching a class or trying to influence a congregation or whatever. It's more about communication, and it's more about how do you provide the right set of instructions, which are both enough instruction but not too much instruction, right? We don't want to overwhelm the LLM. I mean, and again, you talk about context windows and everything like that being really big, but still, what you want to do is you want to get a positive result out of it. You want to give it the right context, the right amount of information, right? So when we build our agent that represents the EHR, we want to make sure that we teach it about the EHR, and we want to teach it in a way that it can make good decisions. And then one of the things we also want to do is we want to recognize that it's existing in a network of other agents, right? So there's other agents out here, right? And we'll put another one down here because I had 3 departments but they're all linked to each other also, and everybody can know about everybody else. Maybe there's maybe there's an agent out here that doesn't know, that only this agent knows about. But regardless, the point is that there's all these agents in this network, right? And each agent has an influence, an area of influence, right? So in this example, right, we might have an agent that is the ER. Actually, you might divide the ER up into a couple of different agents, right? You might have an agent that's the triage agent that's sitting over here doing the triage, right? And then you might have an agent that's the agent that's in charge of how do I get patients out of beds? How do I transfer patients to other or send them home if I need to send them home? I might have another agent that's really overseeing that my nurses are doing what they need to do, and I want to teach each of these agents about what their sphere of influence is, right? And I want them to understand the world around them, and I want to teach them about the world around them and the world, which is the other agents that it can do, that it can interact with. And then what I want it to do is to be able to have the senses that it needs to be able to know what the context is and start doing things that are of interest, right? So as this agent begins to understand that the waiting room is starting to back up, it's letting other agents know about this, and the other agents are able to make intelligent decisions. Maybe the other agents realize after interacting with each other that outpatient actually has a bunch of appointments available right now, and maybe some of these people in the waiting room could get those appointments in outpatient because they're not here for critical things that need to be seen in the ER. They could be seen by an outpatient. Maybe I'm just, this is just as a hypothetical, but the point is that the agents are thinking about that and they're recognizing that, and it's not because they were told or that there's a block of code someplace that says when the waiting room backs up, look at outpatient to see if there are appointments available, right? It's because the agents understand their world and have arrived at a potentially new and unique solution. Obviously, there need to be a lot of checks and balances involved in this, right? I mean, that's the way that our world works, right? We continuously have sets of checks and balances because people are non-deterministic and we can't be guaranteed that they're going to do exactly what we want them to do every time. So we put in checks and balances. For now, I think, one of the key checks and balances is a human in the loop, right? I wouldn't say that any of these agents should send a patient to the outpatient. But what I would say is that these agents could let the triage nurse know that there are appointments available in the outpatient, and ask the triage nurse, do you want me to schedule some of those appointments? Here are maybe the patients we should send over there, right? But a human needs to be in the loop right now, and that that's going to be true, and then there's also going to need to be other agents that are tasked with checking up on agents, and that we can create these networks and checks and balances, much like we do in our society, right? But in the end, my point really here is that how you shape this prompt, what kind of tools you give it, what kind of external memory you bring in, is really much more about a problem of how do you teach? How do you explain the world to the agent than it is about thinking about the rules. And this is, the mind shift that object-oriented programming was trying to go for, but never quite got there, because it was, I would argue, partially because it's built on a deterministic system, so it can't go there. But that's a discussion which we've already had. The vision was that I am projecting my world into the computer, right? The agents are kind of avatars. This becomes the mindset change that I think is going to be the most difficult. I've talked in the past, I mentioned that figuring out how to put real consequences onto agentic systems is also going to be something that's going to be important. But the real mind shift for developers is going to be around understanding that I can't design a system that perfectly deterministically does everything that I want it to do. Instead, what I need to do is teach the system about the world that it's operating in and allow the non-deterministic power of LLMs and whatever models, LCMs, large concept models that are coming out, whatever, the next generation is, allow them to actually do positive things. So I think, interestingly enough, it is true that that there is something to be said for the humanities here, and having a good understanding of the humanities and a good understanding of how do we teach people, which is not to say that LLMs are exactly like people or that they are even intelligent in truth, right? But it's those same techniques and those same ways of thinking about the world that you need to do. It's, political science comes into it, understanding how people are influenced is going to help us understand what the spheres of influence should be, and also concepts like checks and balances that come up in political science. That's going to be important. English is certainly going to be important as we need to write these prompts, or whatever language you're operating in. As we write these prompts, we need to know, how do you write a prompt that actually influences in the way that you want it to influence? And it's not like writing code, right? I don't sit there and just say, if this, do that, if this, do that, and expect the LLM to do exactly what I want it to do. And that I think that mindset shift is going to be, I think, actually really hard for the computing world to wrap their heads around. But once they do, we unlock a huge amount of power and a huge amount of potential. So that's my episode for today. If you've gotten through this far, I would appreciate a like and a comment. Love to continue the conversation with people, and look forward to talking to you in the next episode. Have a wonderful day.